In today's lesson, we are going to find the exact values of the trigonometric functions using a point on the unit second. For this lesson particularly, we will start with the angle pi over 4, which is in the form of radian, which is the same as 45 degrees. So does it matter which one you use? So you use the same thing to find whichever angle, whether in the form of the radian or in the form of the degrees. So this is what we are going to focus on in today's lesson. So let's get started with this one. So let's start with what you might have seen before. Then let's have a right angled triangle here. Let's use this angle, call it theta, and let's have a right angle. Now let's have this side, call this side C, let's call this side B, and let's call this side A. This side, it's called hypotenuse, adjacent, and opposite. So now we need to find sine theta. This S here stands for sine, this O stands for opposite, this H stands for hypotenuse. This C here stands for cos, okay, and this A stands for adjacent, hypotenuse, the H, and then this T here stands for tan, and the O stands for opposite, and A stands for adjacent. So meaning that if I'm looking for sine theta, I must have opposite divided by hypotenuse. So I have opposite divided by hypotenuse, which is in this case opposite, it's B there, so it's B over, now my hypotenuse here we will represent it by C, so it is C. And then let's find cos theta. Cos theta, it is adjacent divided by hypotenuse, so adjacent divided by hypotenuse, and this is the same as adjacent is there, which is represented by A, hypotenuse is represented by C, and the tan is tan theta, we said it's opposite there over adjacent, so it's opposite over adjacent. Then opposite is B, adjacent is A. So sine theta, given this triangle, a right triangle, it is, given the right triangles, sine theta is equals to opposite over hypotenuse, cos theta is equals to adjacent over hypotenuse, tan theta is equals to opposite over adjacent. Now let's find their reciprocals, the reciprocals of this. Let's find them. Reciprocal of sine is CSC. Theta is gonna be the denominator of sine theta divided by its numerator. So it's gonna be hypotenuse, which is C, divided by opposite, which is B. And sec theta for cos is gonna be C over A. Is a reciprocal of that. And the last one is cot theta. It is equals to A over B, which is our adjacent divided by opposite. Okay, this is how you get this using a soccer tool. Now, I want us to use the unit circle. Now let's draw the circle here. Then we can make it a little bit bigger. Okay, I'm gonna focus on this side that looks exactly like a circle. I'm gonna draw my radius here. This radius, it's 1. The radius of the unit circle, it's 1. Let's have a right triangle there, and let's call this angle here theta, and this side from the origin up to there, let's call this x, and the other side from right there, this side, let's call this y. Now, what we are going to do, we need to find sine theta using soccer tool. Now, let's talk about this. The sine theta, what is equals to? We know that it's equals to opposite over hypotenuse. In this situation here, let's have this. Let me have my coordinate here. It's this x, and the other one it's y. These are my coordinates. Okay, at this particular point right here on the circle. Okay, this coordinate, they are right here on the circle, right there. So now, what is sine theta? Sine theta is going to be opposite. Opposite, it's y, divided by hypotenuse. The hypotenuse in this situation, it's 1. So the opposite, it's y, hypotenuse, it's 1. So let's write it down. We have y, which is divided by 1. And the answer is simply y. So sine theta, it is equals to y. Cos theta, it is equals to adjacent divided by hypotenuse. Adjacent, it's x in there that it's attached with our angle, and divide by 1, which will give us x. Okay, now what about tan theta? Tan theta, it is equals to opposite, which is y, divided by the adjacent, which is x, and that is it. Now, what about the reciprocals for these functions? For sine theta, we have CSC theta, which is 1 over y. So what we have in here, we have got the hypotenuse divided by this hypotenuse divided by this y there. Okay, so now for sec here, we are dealing with sec theta. It's equals to 1, which is the denominator here, divided by x, and the reciprocal for tan, it's cot theta, which is equals to the x divided by y. Those are the trigonometric functions. Whenever we have a point on the circle, this will be the answer for that. So meaning that whatever point we have, if we can have it anywhere in the circle, we can have it there, we can have it maybe there. So this will be that if we have it, for example, somewhere there, and then we have got the angle, let's say a beta, for example. So sine of the beta will be determined by what this point is there. If this point, for example, is negative x, and let's call the other one y. So we know that the sine beta will be equals to y, and cos the beta will be a, I'm just going to give a quick example here. Sine beta we know will be equals to y, and then cos beta there will be equals to negative x, and tan beta will be equals to y divided by negative x. That's simple as that. This is exactly what this means. So now, having this understanding, we're going to apply this to find the angle pi over 4. Okay, we are going to apply that. So let's quickly erase this. I'll draw a circle again, drawing a unit circle again. Okay, let's say this is our unit circle. Prefer this to go a little bit up. That's our y, that's our x, and let's have this. It's 90 degrees, and we have our x there, and we have our y there, and this it's 1. Again, now this time around, let's give this angle 45 degrees. We are now focusing on pi over 4, which is the same as 45 degrees. So we give that angle that. Now our goal is to find this coordinates, x and y. We need to find the x and y. What is x and y? So from the unit circle, we know that x squared plus y squared is equals to 1 squared, which is a radius squared. This is a formula for the unit circle from the origin. So now we need to find x. How are we going to do this? Now I want to draw this same triangle here on the side. Let me draw this same triangle here on the side. The way that you might be familiar with, this is a 90 degrees. That's the same as this 90 degrees there. Okay. Then this is 45 degrees. If I've got 45 degrees, which means on the other side, I've got 45 degrees, because this must give me 180 degrees. Now this is the other part of the 45 degrees. This is 45 degrees also. So now this is an isosceles triangle, meaning that these sides are equal because they have got the equal base angles. So now this side we know it is. I'm going to change the colors a little bit here. I will write this 1 in red, okay, then so that I can write it there. This is 1. This side it's 1. Now On the other side, it's x. I'm going to write this x in red. And so this side, it's x. Since this side is x, also this side, we can call that side x. Which means our y there, which is, I can write it in blue, is the same as x in this situation. They are equal because this side, it is equals to this side. So now I'm going to replace this y here by x, and we solve that. So I've got x squared plus x squared equals to 1. The square root, 1 to the power 2, it's 1. So this is 2x squared equals to 1. X squared equals to 1 over 2. Then I'm going to have x to be equals to the square root of 1 over 2. Why not negative? Because x here, it's a length, it's a distance. Distance is always positive. That's why I ignore the negatives. And then this is the same as 1 over square root of 2. Now, you could rationalize this by multiplying this by the square root of 2 divided by square root of 2, and that will be perfectly fine. But for now, I will leave it the way it is. Now, since I found x to be this, therefore, I will continue this side. Y, it is simply 1 over square root of 2. Okay, so now we know the coordinates there. Okay, so now I'm going to remove that. Then I'm going to put our coordinates, okay, for this point. And then I'm gonna open a space there. Let's put our coordinates for x. It is 1 over square root of 2. And for y, it is 1 over square root of 2. Okay, now what we need to find, we need to find sine 45 degrees, which is the same as finding sine pi over 4. So sine 45 degrees, we have learned that it's just going to be y. So it's going to be this coordinate of y, which is, let me use a different color. Which is opposite divided by 1. The cos 45 degrees is just going to be the adjacent, which is x here, divided by the hypotenuse, which is this 1 there, and which is 1 over square root of 2. Now, the last one, it is tan 45 degrees. For tan 45 degrees, it is opposite divided by adjacent. In this case, it's y divided by x, which is 1 over square root of 2 divided by 1 over square root of 2. This gives us 1. Okay, so their reciprocals. This one is CSC 45 degrees. It is just a square root of 2. Okay, and sec square root of 2 divided by 1, 45 degrees is just the square root of 2. Tan has got cot for its reciprocal. is just 1. So now we have found our trigonometric functions for the angle pi over 4, which is the same as 45 degrees. In our next lesson, we are going to focus on finding the one for 30 degrees and 60 degrees. So this is how you can find the exact values for trigonometric functions using a point on the unit circle. Thank you for watching.